Welcome everyone. Today we continue Chapter 1. We will talk about the first rule of building great software, reliability. What does reliability mean? Think about your favorite phone app. You expect it to work all the time. If your internet is bad, or if you click the wrong button, the app should not close or crash. Reliability means the software keeps working correctly, even when bad things happen. Look at the screen. Users have four main needs. First, the app must do exactly what you tell it to do. Second, it must not crash when you make a mistake. Third, it must stay fast, even when many people use it at the same time. Fourth, it must be secure and protect your private data. To build this, we must learn two words: faults and failures. Imagine a car. A fault is like getting a flat tire. Only one small part is broken. A failure is when the car cannot drive at all. As engineers, our job is to build software with a spare tire. We know small faults will happen. We just want to stop small faults from becoming a total system failure. Big companies like Netflix actually break their own systems on purpose to test their spare tires. Now, let us talk about the first big problem: hardware faults. Servers are physical machines, and physical machines always break eventually. Hard drives crash. Power goes out. Network cables get unplugged. If a big company has 10,000 hard drives in a room, simple math tells us that at least one drive will die every single day. In the past, the solution was to buy extra hardware. Companies bought backup power and backup servers. But today, we rent our computers from cloud companies like Amazon or Google. In the cloud, a computer can turn off at any time, without warning. So, our software must be smart. If a server dies, the software must instantly move the user to a new, healthy server. The user should never see an error. Hardware faults are usually random. One bad hard drive does not break the next hard drive. But our next topic, software errors, is much more dangerous. A software bug is dangerous because it is everywhere. If there is a bug in the code, it is on every single server. So, one bad user action might crash all your servers at the exact same time. This is called a correlated crash. Other software errors happen when a small glitch uses up all the computer's memory, or a tiny mistake causes a huge chain reaction that breaks the whole system. This is called a cascading failure. How do we fix this? We must test our code very carefully. We must separate different parts of our app. This way, if one part crashes, the rest of the app stays safe. We also need to add safety checks inside the software. Like a security guard, the software should constantly check itself and raise an alarm if something looks wrong. Now, let us talk about the biggest problem of all. The biggest cause of system failures is not hardware. It is not hackers. It is us. Humans make mistakes. Studies show that a simple typing mistake by an engineer causes more downtime than broken cables. To protect the system from ourselves, we need safety nets. We must design tools that make it easy to do the right thing, and very hard to delete everything by accident. We also need to give engineers a safe place to test their code before real users see it. We call this a sandbox. But humans will always make mistakes. Because of this, we need an emergency undo button. We need tools that let us undo a bad update in seconds. We also need screens with flashing red lights that warn us the moment a system looks sick. To finish this chapter, let us ask a simple question: why is reliability so important? Reliability is not just for spaceships or hospitals. Everyday apps carry a huge responsibility. If a business app stops working, the company loses money. If an online store goes offline, they lose sales and customers go to a different store. But the most important thing is human trust. Imagine you build an app for saving photos. A mother trusts you with the only photos of her baby. If your database crashes and you lose those photos, you break her trust forever. You can never fix that. So, reliability matters. Sometimes, if you are building a very fast test project, you might choose to ignore some rules to save time and money. But that must always be a careful choice. Never a lazy mistake. I hope this gives you a clear understanding of reliability. In our next video, we will learn about scalability. Thank you for watching, and I will see you in the next session.